Hi, welcome to the CET OCW lecture series, and today we'll be dealing with a subject called differential equations. As a continuation for your calculus course in your first semester, we'll be taking a course on differential equations. Before we get to that, we need to go through three topics today, but we need to know what differential equations are. So first, what is a differential equation? A differential equation is an equation that is of the form n into e raised to n by dx raised to n plus an minus 1 e raised to n y by dx raised to n minus 1 plus etc. Equation for x raised to n plus x is equal to x and y is equal to f of x. This is the general form of a differential equation. So why do we need these? The answer is, in almost all physical phenomena, we'll encounter not these things, but we'll find that if we boil down our equations to these forms, we can find general solutions. This is because most of the time we cannot find a whole solution to a problem. For example, take an example of a capacitor. When you charge a capacitor, you don't know the relationship between voltage and time for that capacitor. You only know how fast the capacitor can accumulate charge. So you use that to derive a differential equation, and then realize the actual relationship between voltage, time, and how the value of the capacitor actually influences the entire equation. So that's the importance of differential equations. Almost all physical phenomena, whether you take force, where you encounter force equal to ma, implies F is equal to m into d square x by dt square, and so wherever you have force, you have a differential equation. So as I said, most physical phenomena give you glimpses of things such as this: force, momentum, energy. So to build your description of the physical system, you need to formulate. You don't have any use with an equation such as this. You need to know what the displacement is of an object. There is no use for actually finding the force of an object. End of the day, you need to find a solution for x, here displacement. So whether you are an electronics engineer, or you are a civil engineer, or a mechanical engineer, differential equations influence, or should I say, are a great tool to evaluate tackle problems in your career. And so we'll move on to a special kind of differential equation. Firstly, we'll be talking about ordinary differential equations. So what does this ordinary mean? It simply says that your differential equation does not involve any partial integrals. I hope everyone knows the term partial integral, wherein the partial integral of a function that contains two variables, x and y, with respect to the variable y, is equal to dou f of xy y dou y, or in terms, finding the derivative of f of xy with respect to y, where f is a function of both x and y. So we'll be dealing with not partial differential equations, we'll be dealing with ordinary differential equations. And of that, we have various different kinds. For example, take this differential equation. Y dash is equal to x, xy. You can see here that there's only the first order differential term of y is equal to the product of x and y. You only see one first order differential term, and so we call this a first order differential equation. And we need to talk about another term associated with a differential equation called similar to a degree of a polynomial. If this was squared, you would say that its degree was 2. This is an important way to characterize these differential equations. We are talking about its order, or the highest order of a derivative that is included in the differential equation, and the power of the highest power of a differential term in the differential equation. It's called the degree. So that's what an ordinary differential equation is. So we know how to find these differential equations, or I hope so you know. We'll talk about a simple example. Let's say that dy by dx is equal to our old example xy. Now how do we solve this? We solve it by one of the methods, that is, we'll take dx here, we will bring down y. This simplifies to dy by y is equal to x into dx. Now, if you integrate on both sides, we'll get integral dy by y is equal to integral x dx. It simplifies to log mod y is equal to x squared by 2, and more importantly, plus constant. This is how you solve a differential equation. But don't be misled by the simplicity of this one. Ordinary differential equations can be more tougher to solve, and you may need special tools like Laplace transforms to maybe arrive at a good solution. So let's not talk about big strides like that, and take a look at our first and foremost topic after introduction, that is existence and uniqueness of solutions.